Ions and ionic bonds. We begin our discussion of chemical bonding with one of the ways to distinguish ionic compounds from covalent compounds. Ionic compounds, when dissolved in water, form solutions that conduct electricity. They are electrolytes. The reason they do this is that when dissolved, ionic compounds separate into positive and negative ions. Positive ions are attracted to the cathode, and negative ions are attracted to the anode. This movement of ions allows a current to flow through the solution. But where do the ions come from? Recall that an ion is a charged particle. In order to be charged, an atom or group of atoms must have a different number of electrons than there are protons in the nucleus. Ions can be either negatively charged, more electrons than protons, or positively charged, fewer electrons than protons. Why would an atom have a different number of electrons than protons? This happens when electrons move from one atom to another. And why do electrons move? To achieve a stable electron configuration. Recall that the noble gases all have full S and P subshells, except helium, which has a full S and no P subshell. This electron configuration, 8 valence electrons, is stable. All other configurations are less stable, and most atoms will react to achieve this stable configuration. So lithium, with 1 valence electron, will give that electron to fluorine, which has 7. After the transfer, lithium's valence shell is empty, or the next lower shell is full, and fluorine's valence shell has the stable 8 electrons, full S and P subshells. Once a stable configuration is achieved, no other electron transfers occur. The resulting oppositely charged ions will combine due to the electrostatic attraction between opposite charges, an ionic bond. As we have just seen, atoms can either gain or lose electrons to form a stable configuration. How do you know if an atom will gain or lose? Look at its position on the periodic table. Atoms of main group elements, S and P block elements, will gain or lose electrons to get to the nearest noble gas configuration. Elements in the first group, the alkali metals, will lose 1 electron to get a configuration like the previous noble gas. Elements in group 7, the halogens, will gain 1 electron to get a configuration like the following noble gas. This tendency to form ions with noble gas configurations is called the octet rule because of the stability of 8 valence electrons. We will practice ion formation in class. The Lewis electron dot structures we learned are useful in predicting ions and ionic compounds because it is easy to see how many electrons must move, be gained or lost, for any particular main group element to form a stable electron configuration. Ionic compounds generally form extended crystal structures with alternating positive and negative ions. It is not possible, under normal temperature and pressure conditions, to separate a single unit of sodium chloride. It doesn't form standalone molecules. The NaCl formula simply describes the ratio of sodium ions to chloride ions. Ions may have higher charges than positive or negative 1. For example, magnesium has 2 valence electrons. It can give up both of those electrons to 1 or more other atoms in order to achieve a stable configuration. The charge on a magnesium ion is positive 2. In writing the ion symbol, it is the convention to put the strength of the charge first, then the sign. So we write Mg 2+. Oxygen has 6 valence electrons, so it needs to gain 2 to have a stable configuration. The charge on an oxide ion is 2 negative. The formation of ionic compounds may require more than one ion of one or both elements in order for the electron transfers to give each atom a complete octet. We will practice the combination of ions of different charges in class.